ನಾನು ಮೊಬೈಲ್ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ದೆ. ಓಕೆ, the second method is energy method. Energy method. So law of conservation of energy, a definition we have copied. There are two types of energy. One is kinetic energy. Second one is potential energy. Potential energy can be classified into two types. One is gravitational energy. Another one is strain energy. Right? Potential energy or the gravitational energy is what the gravitational energy is nothing but it is a potential energy which is depending on the height, right, where exactly it is stored. So the potential energy or the gravitational energy formula is mgh. Strain energy means if the body is strained and if you release it, automatically it will come back to its original state. So when it is strained, the energy will be absorbed by the body. That amount of energy or the stored energy is called as a strain energy. So this is more common in the springs, right? If you compress the spring or if you expand the spring, there will be strain energy in the spring that will be released after relieving the load. So that is called as a strain energy that can be seen in this vibrating body. So the next is the figure. Copy this. Am I audible? The screen is visible, right?
Yes, sir.
Okay. So copy the figure. I'll take a simple figure. This is spring. This is a mass. And we have equilibrium position. And this mass is pulled down with the help of external force. And mass is at this position. The distance between the equilibrium position and the new position is called as x. Let us take it as x. This distance is x and the spring is expanded. Is it okay? Now this is k. This is k. So we have forgotten the second position what we have discussed in the last class. Okay, if you apply the load, then it will move a particular distance called delta. That can be considered here, no problem. But I have taken directly. It is because delta is, since the delta is very, very small distance traveled by the mass if you apply the mass. So that's why I've neglected it and I have considered directly the forced distance, that is x. Okay, you can consider delta also, no problem. You can draw the similar figure what we have drawn in the last class. But delta x k into delta is equal to mg. That term, those two terms will be get cancelled right in the first equation itself. So there is no use of that. That can be easily neglected. So that's why I have neglected it and I copied only x, not delta in this case. Okay. Okay. Copy this figure. Okay. Below that figure, according to the law of conservation of energy, according to the law of conservation of energy, what it says, total energy is equal to constant. Total energy is equal to constant. Total energy is equal to constant. Total energy means potential energy plus kinetic energy is equal to constant. Okay, that is equation number 1. Equation number 1. Now, therefore, kinetic energy, what is the equation for kinetic energy? Kinetic energy is equal to half into mv square. Half into mv square. Okay, so it's equation number 2. What is m? M is the mass of the body. And what is v? Velocity of the body. If the mass is pulled down to extreme end, and if you leave it, it starts to move in the upward direction. While moving, the velocity, if you consider the velocity at that particular point, the kinetic energy at that particular point, kinetic energy is gradually increasing and it will be maximum at the equilibrium position. Again, it will be decreasing and it will be minimum at the extreme end. Here, the kinetic energy is 0. Here also, the kinetic energy is 0. At this position, extreme ends, kinetic energy will be 0. Why? Because velocity is 0 at this point. Correct? This is the mean position. If you pull it and if you leave it at this point, it goes up or it moves up and it will reach to this point, right? But at mean position, the body is moving with a high velocity. That's why the kinetic energy at this point is maximum and at this point is minimum and it is 0. And this position also it is minimum or it is equal to 0. You should know what will be the kinetic energy at equilibrium position and extreme position. Extreme position and equilibrium position, the kinetic energy is, equilibrium position is maximum and extreme point is minimum or it is equal to 0. Please remember this. This is very, very important. Okay. You know, according to the law of conservation of energy, energy can neither be created nor be destroyed. So here, the extreme point, please listen to me. Extreme point, you are telling that it is 0. And practically it is 0 only because at this point, if the mass is moving with high velocity, if it is vibrating, once it reaches to this point, it will become 0. Velocity will become 0 because it will be stopped here, right? The velocity will be absolutely 0 at this point. Then only it can move down. Without making 0, it cannot move down. Still further it moves, right? If there is a velocity. If the velocity is 0, then only it will be stopped here and it will come back. While moving up, it will be stopped here and it will come back, right? That's why practically the kinetic energy at this point is 0. But at this point is maximum because it is moving with high velocity because there is a expansion of the spring. That's why the spring force will attract this mass in the upward direction and it is moving with high velocity at this point. Velocity will be gradually increasing and it will become maximum at this point. And again, the gradually decreasing, it will reach to 0 at this point. So this is what the kinetic energy, right? Law of conservation of energy, it says that energy neither be created nor be destroyed. It can be transformed from one form to another form. Let us consider at this point 2 points. We have, you know, at this point the kinetic energy is 0. You know, the energy can neither be created nor be destroyed. It is 0 means the kinetic energy is 0 means you cannot destroy it. You cannot 0. Make it 0 means it is not saying that you have destroyed the energy. No, it is not like that. It is transformed from kinetic energy to potential energy, from one form to another form. Kinetic energy is one form. It is due to the motion of the body. Potential energy is a stored energy, right? So at this point, kinetic energy is 0 but the potential energy will be maximum. What position? At extreme position. Potential energy is nothing but stored energy. Where it is stored? It is stored in the spring, right? Stored in the spring, because spring is having its own stiffness. So there will be strain inside the spring. So it will be stored in the form of strain energy in the spring. Means the kinetic energy, the entire kinetic energy will be transformed into potential energy. And at this position, the potential energy is maximum and kinetic energy is zero. Means all the kinetic energy will be converted to potential energy. Same thing will happen here also. At this point also, kinetic energy will become zero, since the motion or the velocity is zero, but potential energy will be maximum at this position. Am I audible? Hello? Can anyone answer? Am I audible?
Yes, sir.
Audio is clear? Okay. So
Yes, sir.
this is very, very important concept, because we are going to take this concept to solve the problems. All the problems will have this concept. Is it okay? This is very, very important. Where exactly the kinetic energy is maximum, where exactly the potential energy is maximum. Now we should know how the kinetic energy is transformed into potential energy transforms into kinetic energy. So we have taken two experiments, and uh, we have the values of potential energy and kinetic energy. But we need to consider the middle point. You know, kinetic energy at the midpoint is maximum, that we have discussed in the previous case, right? So here the kinetic energy is maximum at the mid position or the equilibrium position, because the body is moving with a high velocity. High velocity. So that is kinetic energy is maximum. Now, what will be the potential energy at this point? Potential energy will be zero at this point, because there is no stored energy. Equilibrium position, there is no stored energy, right? See this position. Is there any energy stored in the spring? No, there is no energy stored in the spring. It is equilibrium position. It is equilibrium position. So the potential energy is zero at the midpoint, but the kinetic energy is maximum. And as it moves in the upward direction, slowly the potential energy will be increasing. The kinetic energy will be decreasing as it moves in the upward direction. As it moves in the upward direction, kinetic energy, because the velocity goes on reducing, as a result, kinetic energy will be reduced, but the spring is compressed slowly. That's why the potential energy will be increasing, and it reaches to maximum value at the extreme point. Similarly, same thing will happen in the downward direction also. Due downward direction, kinetic energy, because the velocity slowly decreases, and kinetic energy slowly decreases and will become zero at the extreme point. At the same time, potential energy will be increasing from the point as you move in the downward direction, and it will reach the maximum value at the extreme end. So this is what the transformation of energy from one form to another form, or kinetic energy to potential energy to kinetic energy. This is what the energy concept we are going to consider while deriving the equation for the natural frequency of a vibrating body. Okay, so next is we have the equation for kinetic energy, right? Kinetic energy is equal to half into mv square. You know that's why I have written directly, but we need to write the equation for the potential energy. Potential energy. You know the significance of potential energy and kinetic energy at the extreme end and equilibrium position. So next is potential energy. Potential energy is equal to how do you find the potential energy? Let us consider you are going to apply the mass or load, right, or the force. You are going to pull it down. You are going to pull it down. As a result, if you apply the load in the first cycle, very first cycle, because it is a free vibration, during the first cycle, you are going to apply the load in the downward direction, and it will move to the extreme point at a distance of x. Here, the x, or the displacement of the mass, is depending on the applied force, right? As you apply the load, or as you increase the load, the distance also increases, or the displacement or the deflection will be increased. If you draw the curve or the graph, so I'm going to draw the graph. x versus displacement, or it is called as deflection. Okay, deflection or displacement. Deflection versus force. If you apply the force versus deflection, if you draw the graph force versus deflection, so the force and the deflection will be a straight line. The curve will be straight line. As you increase the force, the displacement also increases. This is the curve. This is the curve. So what is the maximum distance? So I'm going to displace it, or the deflection, I'm going to get it as x is the maximum displacement, and this is what my x maximum displacement. The corresponding force is F. Okay, this is F. Okay, if you take this is what the force F is equal to. Now, what is the value of force? The force is, as you apply the load, that force is equal to K into X, right? This force is equal to, because it is an equilibrium condition, means the applied force is equal to K into X, that we have seen in the last class. So the resisting force, or the force applied, or the resisting applied, is equal to the resisting force by the spring, K into X. This is what X. So the spring stiffness into X, the displacement, is equal to the applied force. This is what F is equal to Kx. So F is equal to K into X. This is what a maximum force. That force value is given by K into X. And if you drop it to x-axis, this is what okay. If you drop into x-axis, that will be x value. This is x, right? And if you take the area under the curve, okay. So area under the curve, the potential energy is nothing but area under the spring force versus deflection graph. So how do you find out the potential energy? The potential energy can be found by taking the area under the curve of spring force, or it is called as spring force. Okay, the spring force into deflection. This is what the spring force is given by K into X. So K is a constant, it is a spring constant, X is the deflection. So K into X, here x-axis, deflection is there, the maximum value is X, the displacement is X, the corresponding force is F. Or the spring force is F. So how do you find out the potential energy? Potential energy will be found by taking the area under the curve of spring force versus deflection graph. You can write it as versus deflection graph. Understood? It is equal to area under the curve. Now, how do you find out the area of a triangle? The curve, the area under the curve is like a triangle, right? And what is the area of a triangle? Half into hello, height is F, right? Into base is X. Half into F into X. F is the height. What is the spring force? What is the spring force value? That is K into X. Now, what is the base? Base is X. Half into F into X. So it is equal to. What is F? F is K into X. So the final answer for the potential energy is equal to half into Kx square, equation number 3. Please plot the graph, then write the equation for potential energy. First, you draw the graph. Finished? Hello, finished? Okay. From equation number
sir.
1, from equation 1, what it says? Equation 1 says kinetic energy plus potential energy is equal to constant, right? So kinetic energy, what is the kinetic energy? Kinetic energy plus potential energy is equal to constant. So kinetic energy equation, half into mv square plus potential energy equation, half into kx square is equal to constant. Is equal to constant. Differentiate the above equation. Differentiate, copy it. Differentiate above equation. Differentiate the above equation with respect to time. With respect to time. Okay. Differentiation of the above equation is nothing but half into mv square plus half into kx square is equal to differentiation of constant with respect to time is 0. Okay, first term, half into m is constant, m, v square, differentiation of v square, 2 into v into dv by dt plus half into k is constant into differentiation of x square, 2 into x into dx by dt is equal to 0. 2 will get cancelled, right? Here, the final equation, m into v into dv by dt is nothing but differentiation of velocity with respect to time is acceleration, right? Plus k into x into dx by dt, velocity v is equal to 0. See, v is a common term, cancelled. The final equation, m into a plus kx is equal to 0. I'll rewrite the equation, a plus k by m into x is equal to 0. This is what my equation number 4 for SHM. What is SHM equation? For SHM, we have an equation for SHM, a plus omega n square into x is equal to 0. This is what SHM equation. You can see the first derivation, very first derivation. Okay, comparing equation 4 and 5. equation 4 and 5. What it says? Equation 4 and 5. A plus k by m into x is equal to A plus omega n square x. Correct? Is it visible? Shall I write it in the next slide?
Sir.
Shall I write it in the next slide? Okay. Okay. So A, what is the equation? A plus k by m into x is equal to A omega n square into x. Both are equal to 0, so you can equate it, right? Okay. So if you compare this, what is the similar terms? So omega n square is equal to k by m. Therefore, omega n square is equal to k by m. Omega n is equal to square root of k by m. This is for the angular velocity equation, that is radians per second. This is the angular velocity equation. Is it same for the previous equation or the previous derivation? D'Alembert's principle? Same equation we are getting, right? So you should get both the same equation for both the conditions. D'Alembert's principle as well as energy equation, right? Okay. So omega n is or the natural frequency equation. Fn is equal to omega n by 2 pi, right? That is the equation. Is equal to, what is omega n? 1 by 2 pi into k by m. K by m. Omega n is nothing but k by m, 2 pi divided by 2 pi. This is what the natural frequency equation. I think getting the same answer for D'Alembert's principle also. Right? Unit is hertz for cycles per second. Next, time period. TP. Time period TP is equal to 1 by Fn is equal to 1 by Fn is nothing but 2 pi square root of m by k. Not k by m, it is m by k seconds. This is what the end of the second derivation by energy method. Energy method, it is very simple, but the thing is the difficulty, all of you copied this? A difficulty in the potential energy. While taking the equation of potential energy, you need to draw the graph, spring force versus deflection, and take the area under the curve, that is half into base into height, right? Base is x, height is f. F value is kx, substitute it, that's all. We'll get the equation. Rest all same. So only till this equation number 4 is important. Once you get the equation number 4, the rest all is similar to the previous one. Okay, I hope you copied. Let us go to the next slide. Next concept. Hello. We have third one, Rayleigh's method. Okay. Next is the third one. Rayleigh's method. Rayleigh's method. Write down below that. In this method, the maximum kinetic energy at mean position within bracket where the potential energy is zero, within bracket where the potential energy is zero, close the bracket. I repeat, in this method, the maximum kinetic energy at mean position within bracket where the potential energy is zero, close the bracket, is made equal to the maximum potential energy is made equal to the maximum potential energy within bracket strain energy, close the bracket, at the extreme position, within bracket where the kinetic energy is zero, close the bracket. Avanish is there? Avanish,
Yes, sir.
okay, copying or not? You have not uploaded the first module, that is balancing of rotating masses. I'll put 0 for that, okay?
I'll do it, sir.
How many times I told you, man? While doing the problem only I told you to send it. Okay, next line. Let the motion be a simple harmonic. Let the motion be a simple harmonic motion. Therefore, the displacement is given by let's take a figure. Copy this figure. M so the distance traveled by the mass is x. Let us take x. Okay, x. Therefore, the displacement is given by equation x is equal to a sine omega nt. This is what the displacement equation for SHM that we have seen in the last derivation, the very first derivation, right? X is equal to a into sine omega nt, where a is the maximum displacement, where a is maximum displacement where a is the maximum displacement from the mean position. From the mean position. Okay, So therefore, this is the equation number 1. Differentiate the equation number 1. Equation 1. Differentiate the equation number 1 with respect to time. What it says? Differentiation of x with respect to time dt is equal to v, velocity. Differentiate this equation. What will we will get? Omega n a cos omega n t. Equation number 2. This step is already done in first derivation. So what will be the maximum velocity? For maximum velocity, V max is equal to omega n a. Cos 0 is 1. Cos 0 is 1. That is the maximum velocity. Equation number 3. Next is, according to the Rayleigh's principle, according to the Rayleigh's principle, what it says, first sentence we have given, according to the Rayleigh's principle, the maximum kinetic energy at the mean position where the potential energy is 0. Mean position, kinetic energy will be maximum, but potential energy is 0. At the same time, at the extreme end, potential energy will be maximum and kinetic energy is 0. Kinetic energy is 0, right? That is the concept. Means at the so kinetic energy will be converted to potential energy at different position, right? That is the meaning. Means let us consider at extreme position. So let us consider at extreme position. Extreme position is this one, right? This is what extreme position, and this is what the extreme position. This is mean position, right? So I'll take a new figure for this. Okay, here. This is a spring. Okay, and we have a mass. We have a mass. So this is what a mean position. This is what the maximum position or extreme position. Let's take extreme. And one more extreme position is there. This is extreme. Right? So here x is equal to, x is equal to a. X is equal to a here. Here x is equal to 0. And if you take the potential energy and the kinetic energy at the extreme position and the equilibrium position, here potential energy is maximum, but kinetic energy is 0. Here kinetic energy is maximum, potential energy is 0. Here again potential energy is maximum. Please write down. Kinetic energy is 0 here. Because the displacement is 0 or velocity is 0 at this point. So extreme position, kinetic energy is 0, but potential energy is maximum. Right? According to the Rayleigh's principle, at extreme end, potential energy is maximum, but at mean position, kinetic energy is maximum, potential energy is equal to kinetic energy, because all the potential energy, whatever the maximum potential energy, is converted to kinetic energy at the mean position. Means you cannot destroy the energy or you cannot create the energy, but you have transferred the energy. All the potential energy will be transferred to kinetic energy. That indicates potential energy is equal to kinetic energy. According to Rayleigh's principle, potential energy, or you can take it as kinetic energy first, okay? Kinetic energy at mean position is equal to potential energy at extreme position. This is what the Rayleigh's principle says. What it says, energy can be converted from one form to another form. That is the law of conservation of energy. But according to the figure, what we have decided is kinetic energy will be maximum at the mean position, potential energy will be maximum at extreme position. That's why energy can be transformed from one form to another form, kinetic energy to potential energy to kinetic energy. But it cannot be destroyed or cannot be created. Kinetic energy will be converted. All the potential energy will be converted to kinetic energy at mean position, because kinetic energy will be maximum here, potential energy is 0. Where it goes, this potential energy is 0. That energy is converted to kinetic energy. Similarly here, potential energy will be maximum, but kinetic energy will be 0. Kinetic energy, all the kinetic energy will be converted to potential energy and it will become maximum. So that is what the implication of this Rayleigh's principle. So according to the Rayleigh's principle, kinetic energy at mean position is equal to potential energy at extreme position. Okay. Now, what is the kinetic energy equation? Therefore, kinetic energy is equal to, what is the kinetic energy equation? Half into mv square. Half into mv square. So that is the equation, it is given already. So where the kinetic energy will be maximum? Kinetic energy is maximum when V is equal to V max. If the velocity is maximum, automatically the kinetic energy also maximum. What is the V max equation? So kinetic energy is equal to half into m V max square. It is equal to half into m into, what is the V max equation? Omega n A whole square. This is what equation number 4. Please copy this, do it fast. I'll try to upload all the videos of this module to YouTube, and I'll paste the link, okay, in the Google Classroom. You can refer it. And one more thing, 11th class, 11th of this week. I think it is on Tuesday. Sorry, not Tuesday. Today is Monday, right? Wednesday it seems. Right? So you'll have an assignment. I have uploaded the question to Google Classroom. You can go to the post. There you can see 5 questions on Hartnell governor, 5 problems on Hartnell governor. Any 3 will be asked. You just prepare for all 5 questions. Any 3 will be asked in the assignment. Assignment questions, you need to write it in the A4 size sheet and upload it. It is similar to the examination, what we have done. Okay? Any 3 questions will be asked in the assignment. Assignment questions are uploaded to Google Classroom. You can refer those questions. Any 3 will be asked. There are 5 questions on Hartnell governor. Copied? Hello? Copied the equation? 4, equation number 4. Can anyone answer? Only 5 minutes left. Hello?
Yes, sir.
Copied? Figure also, you need to copy the figure also. Otherwise, you will not come to know this Rayleigh's principle. Okay, I hope you copied. Let us go to the next slide. Similarly, potential energy is equal to area under spring force versus spring force versus deflection curve. That is similar to the previous derivation, deflection curve. What it says, spring force versus deflection curve. That is a force, spring force, F. This is deflection, X. Deflection X. The curve is a straight line curve and force will be maximum at this point. If you draw the curve or if you drop this point, that is X, maximum displacement. So area under the curve will gives you the potential energy. This value is F, maximum force, is equal to K into X. K into X. So area under the curve, it is equal to potential energy is equal to area under the curve half into half into K X, that is Kx, half into F into X. It is equal to half into F is K into X into X. Therefore, potential energy, final equation, half into Kx square. But potential energy is maximum. When it will become maximum? Can anyone tell? When it will become maximum? Potential energy will be maximum when? The maximum, three conditions is extreme end, right? At extreme end, potential energy is maximum. Now, what is the displacement at maximum end? X is equal to A. When X become A, then automatically potential energy will be maximum. Potential energy maximum when X is equal to A. It is extreme position. Extreme position. X is equal to A. Substitute it. Potential energy is equal to half into K into X is A square. Therefore, this is what equation number, what? 4 is 5. So, according to Rayleigh's principle, what it says, potential energy or kinetic energy is equal to potential energy. Next hour ಏನida? Equate ಮಾಡಿ. ಏನಿದೆ kinetic energy half into m omega n a square. Omega n a square is equal to half into K a square. Correct alla? Half will get cancelled. A square will get cancelled, right? m omega n square is equal to k. Therefore, omega n is equal to square root of k by m. This is angular velocity. But natural frequency is equal to omega n by 2 pi is equal to 1 by 2 pi into square root of k by m hertz. Time period Tp 1 by Fn is equal to 2 pi square root of m by k. Finished? Copied? Hello?
Yes, sir.
Copied or not?
Copied.
You want me to show the slide once again? Okay, please copy this, do it fast. Previous slide is this one. Those who have finished, you can leave the meeting, no problem. This is the previous slide.